Hi, this is a video presentation for the ICP7. So, this here we have downloaded various libraries required for uh, machine learning algorithms. So, here we are loading the data. So, we are loading the diabetic data into the data, and then we are initializing the Spark session builder, and then we are reading we are reading the data using the format of CSV, and we are inferring schema and giving header as true. So we have loaded the file into the data, and then we are loading k-means and vector assembler. So vector assembler is used to vectorize the data in the data set as a feature set. So when we give the columns, input columns and output columns using these hyperparameters, and then we transform the data using assembler.transform of data. So the data is applied to the assembler, and we got the final df. So this is how the data frame look like. And then we are importing standard scaler to scale the values so that they have the even weightage, and then we are giving input column as feature because feature is created from the assembler, vector assembler, and output as a scaled features. So we are fitting it to the final df, and we are transforming the data, and then we are initializing a k as 3 for k means clustering and fitting the final df data, and we are computing the cost, and we got the mean square error as this. So next we have used the auto data set. So we have read the auto data set into auto data, and then we are using label encoder in order to encode the data which has non integer values. So the fuel system and engine type are label encoded to the numerical values, as you can see here. So and then we are selecting the columns which are relevant by looking at the description of the data set, and then we are importing logistic regression from this library. And so logistic regression is given with 10 iterations as a hyperparameter, and so we are using vector assembler as similar to the case in k-means. We are giving input columns and output column as feature, so it creates a feature and engine type as output because we have selected feature and engine type from the vector assembler into vhouse. So we are splitting the data with 80-20 percentage into train and test data respectively, and then we are using linear regression, and so we are giving feature columns and label columns. So feature column is with features and label column is engine type, and we are giving iteration as 10. So we are fitting the train data, and we are trying to evaluate uh, the model. So when we tried, when the root mean square error is 0.28, and R2 value is 0.914. Then we are giving the test data in order to evaluate the model. So the predictions is it select the prediction, engine type and features. So to show the output, so it is a prediction, it is an engine type. So for the 3 it has shown 2.98 which is close to 3, and then for 5 it has shown up to 4.39. Next we are using decision tree regressor in order to estimate the class. So we are fitting the features and label column as engine type, and then fitting the train data, and we are transforming the model with test data, and we are using regression evaluator to evaluate the data with label column as engine type and prediction column as prediction. So this gives an root mean square error of 0.301. And then we have used random forest classifier. So for random forest classifier, we have used the same columns, the label column as engine type and feature column as feature, and then we are fitting the data and similarly transforming the data with the test df, and we are using multi classification evaluator to predict. So the output is 0.8689. So this is the evaluated output. So the naive Bayes has performed poorly in this with this data set because the most of the columns are correlated with each other, so it fails with the core assumption of naive Bayes. So these are the various outputs for the task. Thank you.